Hello there. Yes, well, welcome back again to our series of teachings on the chemistry jam syllabus. And today we are going to be looking at a different topic, a whole new topic in the chemistry jam syllabus. And the topic that we are looking at today is titled air. Air. How many of us know what air is? Okay. All right. I guess there's no one that does not know what hair is. We feel it, we use it, and it's a very, very important part of our existence, either as a human being, even for animals, and even plants. It's a very, very major component of life. Air is very, very essential. And today we are going to be looking at air as a topic in the chemistry jam syllabus. And my name is Anjori Oluwafemi Excel. I'm doing this introduction for those that may be joining in for the first time. So I am Anjori Oluwafemi Excel, and I am your tutor for this series of lessons on the chemistry jam syllabus. Okay, I hold a BSc in chemistry from University of Ibadan, a postgraduate diploma in science education. I also hold a Master's of Science in Environmental and Analytical Chemistry from the Redeemers University at the Osun State. Okay, and I'm going to be your teacher for this class and subsequent class as we go along in this journey. Okay, let's start with what our learning objective is. For this particular lesson, it is expected that by the end of this lesson, students should be able to, one, deduce reasons for the existence of air as a mixture. Number two, identify the principle involved in the separation of air components. That's the second objective. And then the third objective is that we must be able to deduce reasons for the variation in the composition of air in the environment. And finally, highlight the uses of some of the constituents of air. Okay, let's move into the first slide and define what air is, and then we'll move on from there. Or before I jump into the next slide, who can give us a definition of what air is to your own understanding? What is air? What is air? Yes. So if you have anybody that want to try, please just put your response in the comment section. I'll pick it up and then I will do justice to it. Okay. So air. We want to start with the definition of air. What is it? How do we define air now? Okay, look at the screen. You can see that air can be defined as what? A mixture of gases. Air is a mixture of gases that forms the Earth's atmosphere. Air is a mixture of gases that forms the Earth's atmosphere. Okay. All right. So if you have the atmosphere in the atmosphere of planet Earth, there are different gases, and these gases are mixed up together, and that is what forms, the Earth's atmosphere. So that is what a simple definition of air is. Okay. Now let's look at the composition of air. Now, air is made up of different gases. We've established this before. And they occur or exist in varying proportions. Now, the first composition of air that we should take note of, and that is more like the predominant composition of air, and that's nitrogen. Nitrogen composition in air is about 78.09% of air is made up of nitrogen. That's a very large chunk of air. Then that is closely followed by oxygen. Oxygen makes up about 20.95% of the air in our atmosphere, and then argon 0.93%, carbon dioxide, which is also important for plants, 0.04%, and then all the gases in small amounts. And not only that, water vapor is also a constituent of air in varying amounts, along with dust particles that are also a component of air. So that little, like the pie chart here, so to speak, gives us a diagrammatic reflection or representation of what air composition looks like. Okay, I haven't said that. Let's move on to the next one and look at this. Reasons for the existence of air, or sorry, reasons for the existence of air as a mixture. Why do we say that air exists as a mixture? If you remember in our previous class, the very first class that we had, we talked about what a mixture is and how to identify a mixture. Don't forget that we said a mixture is formed when two or more substances, different substances, combine in such a way that their characteristics are retained. That is a definition of mixture that we established in our first class, you know. And also, mixing of substances does not involve any chemical reaction, and it is usually possible to separate the individual components of a mixture by physical separation method. So we've established this before from our previous class. But venture, you did not see that, you've not seen this video, please go back and call up that video and watch the video so that I can be able to understand this particular slide very well, because I'm going to be dwelling on the knowledge that we've established from the first lesson we had. So air is therefore referred to as a mixture. Why? Because of the following. Number one, physical separation. It is possible to separate air into its constituents or components, constituent gases or component gases using physical methods. And some of the physical methods that we can employ to separate, or the physical method that we can employ to employ rather to separate air into its constituent gases or gas as the gases, yes, that is the plural. Okay. Constituent gas is fractional distillation. So one of the reasons why we say air is a mixture is because it can be separated physically. Constituents of air can be separated by a physical method. Very, very important that we establish this. So we deploy a physical method, an example, fractional distillation, and then we can separate the constituent of air. And that's why we say air is it exists as a mixture. Okay. Number two reason is because the identities of the constituent gases in air are retained. And from our definition for mixtures, we say there are two or more substances that come together, but they retain their properties. So for air, also the same is the same holds true in the sense that the constituent that makes up air, they retain their properties. Carbon 4 oxide have a dynamic and unique properties or property that is different from oxygen. Oxygen has a different property that is from nitrogen, and they all retain their properties. And that is why air shows chemical and physical properties of all the gases present in it. Okay, so another reason why air exists as a mixture is because the composition of air is not fixed. Is not fixed, but varies with time and place. And we're going to still look at this variation in air composition. We're going to look at it very shortly. So the composition of air is not fixed, but it varies with time and place. This is an example of or a property of mixture, and this is what is reflected even in air. So their composition is not fixed. They vary with time and place. Therefore, it cannot be defined by a fixed chemical formula. This is the property of a mixture. And that is why we say that air is a mixture. So with these 3 points, I've been able to establish now that air indeed exists as a mixture. If you have any question on what I've said so far, on my explanation so far, there's an area that is not so clear, please put your questions in the comment section. I'll pick them up and treat them accordingly. Thank you very much. Now let's move on to the next slide now and talk about the principle for separation of air into its components. Air can be separated into its component, just like we have been able to establish before. And what principle do we employ to separate air into its components? Now, we said that air is a homogeneous mixture of gases. The gases blend together and they have a uniform composition. So air is a homogeneous mixture of gases. It consists of gases like, we've said this before, nitrogen, oxygen, carbon dioxide, argon, etc. in different proportion. Now, since air is a homogeneous mixture, We need special separation techniques in order to be able to separate the component of air or the constituent of air. Now, this technique that we can deploy to separate air into its constituents is called fractional distillation. So fractional distillation is a technique that is used to obtaining different components from the air. Now, for us to be able to separate air into its constituents, we have to go through two steps. The first step is the conversion of air into liquid air. So we get air in, just like you can see from the diagram, air flows in, it is compressed, pressure is exerted on the air, and then it is liquefied. After the liquefaction or the liquefaction of air, the next thing that we do is to send the air into a fractionating column where fractional distillation will act on the air constituent that has been liquefied. Now, when you employ fractional distillation, it separates them out at their varying boiling point, different boiling points, you understand? So you have a gas like nitrogen gas coming out at 100 minus 190 degrees Celsius. You have a gas like liquid oxygen that will be coming out at minus 185 degrees Celsius. And all other components have their different boiling points, and then they separate out accordingly. So this is the process through which air components can be separated. Don't forget, the method is what? Fractional distillation. And don't forget that it's a two-step process. First, liquefaction or compression of air into liquid air. Number two, fractional distillation. So please, don't let us forget that. All right, now, let's move on to the next one and look at the reason for the variation in the composition of air. Why do we have variation in the composition of air in the environment? Variation in the composition of air in the environment. Now, the following factors can be alluded as reasons for variation in the composition of air in the environment. Now, one of the factors that can be alluded for this variation is temperature. Temperature. Now, temperature significantly affects the composition of air in the environment by influencing the amount of water vapor it can hold. So temperature have an influence in the variation in the composition of air in the environment by affecting or influencing or impacting on the amount of water vapor that air can hold at a time. Now, this causes variation in humidity level and also by impacting the formation of certain pollutants like ozone. When the temperature rises, there's a likelihood of ozone formation in the air or in the atmosphere. And when ozone forms, because it's very, very reactive, it's very, very reactive. You discover that it can react with other components of air, and then it will affect or to a certain extent impact their composition in air at time. So what happens now is that when temperature rises, the humidity level will increase. The quantity of water in water vapor that air can hold on to also increases, so to speak. It increases the water vapor, increases the humidity. It results in formation of certain pollutants or pollutants like ozone, and it now have a bearing on the composition of air at time. Now, we are going to look at this closely by looking at the different things that happens when temperature rises and how they impact or have a bearing on the composition of air in the environment. Now, we talked about temperature. We said when the temperature rises, air can hold more water vapor, leading to increased humidity. So the humidity level increases. Conversely, cold air has a lower capacity for water vapor, resulting in lower humidity. So water vapor level will increase when temperature increases also. So the composition will be impacted on, by that. Also, ozone formation. When high temperature, we said high temperature promotes the formation of ground level ozone, a pollutant through photochemical reaction involving sunlight, nitrogen oxide, and volatile organic compounds. And when ozone forms in the atmosphere. Now, one of the things that we notice is that it can also make air to be very, very reactive. So a component of air will now it can react with other components of air and then impact the composition of air. Okay. Another influence that temperature has, especially increased temperature on air, on the composition of air, is that air pollutant dispersion. When temperature increases, when there's an increment in temperature, it can result in the dispersion of air pollutants, potentially reducing their local concentration in some situations. So when there's a high temperature, there's an increase in temperature, you discover that air pollutants will be dispersed in air. And this can affect their local concentration in some situation. Now, finally, an impact or influence of temperature is that it also results in what we call wildfire. Wildfire. For some of us that are very, very conversant with what happened early 2025, I think around January 2025, if I'm precise, in the state called California in the United States of America, you saw a raging fire. It just kept on burning and destroying properties, killed wildlife and destroyed so many things in its path. Now, when there is wildfire, and most of the times, as a result of increase in temperature, can result in wildfire. Now, extreme heat can contribute to increased wildfire activity. So when the heat is so much, it encourages wildfire activities. And now, when there's wildfire, what happens is now it releases large amounts of particulate matter into the air. So wildfire will release gases, because the wood is burning of metal, burning of plastic and all that. So certain particulates are released into the air, certain gases are released into the air, and this significantly alters air quality and composition. So it significantly alters what? Air quality and air composition. So these are ways in which temperature impacts or influences composition of air in the environment. Now, the second factor that we need to consider is altitude. Altitude. Okay. Now, as altitude increases, the composition of air remains relatively constant. But the density of the air decreases due to water air pressure and due to lower air pressure, pardon me, meaning there are fewer air molecules per unit volume, including less oxygen, less nitrogen, less carbon dioxide, effectively making the air thinner at higher altitude. This is why people experience reduced oxygen level when climbing mountains. For some of us that have had the privilege to climb, high places, maybe mountainous areas and places that have high altitude, so to speak. I'll give you an example of my own experience, and I know some of you will have other experiences too. Now, I remember the first time I climbed Olumo Rock in Abeokuta. As we begin to ascend, started going up the mountain or the rock, so to speak. One of the things that I noticed was it was as if I could not breathe properly. It was as if the air around me was not as sufficient as it was. I was heaving, I was sighing, and all that like that. And the reason is because as you go higher, there is a thinning of the air, so to speak. The volume of oxygen that you have access to will reduce. The volume of nitrogen and other composition also will reduce. So when you climb higher, the altitude, as you climb higher in the plane, maybe you're going onto a higher altitude and all that. One of the things you notice is that there will be what? Impact on the composition of air. Now, notes, it's not as if the components reduce in any way, but what happens is that what you have access to will reduce drastically. And that is how altitude impacts the composition of air in the environment. And that's why sometimes when you see people climbing big mountains like Kilimanjaro, like Mountain Everest, and so on and so forth, you'll be asked to probably take a little tank of oxygen and all that just to help breathing as you climb higher and all that. So now, what are the key points about altitude and air composition that we need to take note of? Now, number one, there is no significant change in the percentage of air, even as you move to high altitude. There's no significant change in the percentage of air. So while the absolute amount of each gases decreases with altitude, the percentage of each gas in air or in the air, like oxygen being around 21%, generally remains the same. So you must understand this, and we need to establish this. Very, very important that we establish this. Okay. Now, the second thing that we need to also establish is that there is reduced air pressure. As you go higher, you move high to higher altitude, there's reduced air pressure. So the primary factor impacting air composition at higher altitude is the decrease in air pressure, causing air molecules to want to spread out. And that's why I said the air looks thinner, so to speak. So the major reason that impacts the composition of air at higher altitude is the decrease in air pressure, causing air molecules to want to spread out. In summary, as altitude increases, the overall density of the atmosphere decreases, leading to a reduction in the number of gas molecules. While nitrogen and oxygen remain the primary component throughout, the relative concentration of trace gases like water vapor and ozone varies significantly. So we need to understand this and take note of this. So far we have been able to establish two main factors that um, we can allude to the variation in the composition of air. And don't forget that we said one can be temperature, and we gave reasons why temperature can impact or influence, the composition or impact variation in the composition of air in the environment. And the second factor is altitude, which I just explained. If you don't understand any of this concept that I've just explained now, please put your question or that area that you're not clear about in the comment section. I'll pick it up later and then I will explain in the next video. Thank you. All right, now let's look at the uses of some of the constituents of air. Like we said, air is made up of oxygen, nitrogen, carbon dioxide, argon, and so on and so forth, like that. Now, one of the constituents of air is oxygen, and it can be used for the following. It's used for life, for sustenance of life. So it's oxygen is necessary for respiration and combustion. Respiration is very, very germane, very, very important to our existence as humans. So respiration um, is one example of the use or one of the uses of oxygen. And for combustion, people still need air. We need air to mix with our fire for cooking and all that. Even in our fuel tank before it can burn and all that, you need air that will mix with it. And the one major component of air that mixes up is actually oxygen. So for respiration and combustion, so we said combustion, oxygen supports burning, which is used for cooking, generating heat and electricity, and running vehicles and industries. Okay. Another constituent of air is carbon dioxide. And carbon dioxide is very, very important to plants because without carbon dioxide, plants cannot go through a process called photosynthesis. So photosynthesis, plants make use of carbon dioxide from the air to make food, and also they produce oxygen alongside also. Carbon dioxide can also be used as a component in fire extinguishers that are used in extinguishing fires. Then also a major culprit for global warming. So large amount of carbon dioxide are produced when coal, oil, and gasoline are burned in cars and power plants. And this results in global warming, which is a terrible, terrible phenomenon. And most countries in the world are doing all that they can to reduce global warming. So CO2, carbon dioxide, is a major culprit in that instigate or impact on global warming. Okay, so uses of some of the constituents of air. We are still looking at it. Nitrogen is another constituent of air. In fact, is the major constituent of air. Nitrogen can be used by bacteria in what we call nitrogen fixation. Nitrogen is also used in food industries, in which a nitrogen atmosphere is created. It creates an unreactive atmosphere in the food industry, and it reduces spoilage and the growth of pathogens and what's it called? Agents that can bring about spoilage or that can damage food that is produced in those industries. So nitrogen is also used for fire suppression. Nitrogen gas is used in fire suppression system, and the reason is because nitrogen is much denser than air and much denser. Yes, than it's quite dense, so it can actually blanket the fire and then suppress it accordingly. Nitrogen is also used in stainless steel manufacturing company. It's one of the compositions that you put together to make stainless steel. Can also be used in aircraft fuel system. It's also used in aircraft fuel system. That's nitrogen. Now let's look at some of the uses of helium now. Helium in balloon, some of us have watched movies before, and you see a floating balloon, it's just been moving like that slowly in the air. Now, what fuels up that thing that makes it to be able to move? It's propelled by helium. So helium gas that is being burned will bring about, the movement and then helps the balloon to move from one point to the other. So helium is commonly used to fuel balloons due to its low density and non-flammable nature, making it safer than nitrogen. Okay. All right. Xenon is another constituent of air, and this has found usage in medical imaging and like CT scans and some X-rays and all that like that. So xenon has also found usefulness in anesthesia, and with this is because xenon has what we call a minimal side effects, and it also gives patients rapid recovery times compared to other anesthesias that have been explored or have been used. And also, its inert nature reduces the risk of adverse reaction, making it a subject of interest in medical research. For those of us that know about this guy called Elon Musk, the owner of Twitter, formerly Twitter, now X, he also has a ownership. He owns a spaceship company, and one of the things it does is that it will just fly people to the moon or fly them to the International Space Station and so on and so forth like that, using a spacecraft. And this spacecraft, one of the things that are used, as a propellant or in the propulsion systems for this spacecraft is xenon. So they can be used. They generate the thrust, that will push the spacecraft and make them break through and move into outer space. So xenon is used in propulsion system for spacecraft. Okay. We also have neon lightning like krypton and so on and so argon. Argon is used in welding and metal fabrication, and majorly it's because of the inert nature of argon that it enables it to be able to, feature as a useful component for welding and metal fabrication. And it's also used in food preservation. And also the major reason is because it can create an inert environment, and this prevents reactions that can lead to spoilage. Okay, all right. So those are the uses of some of the constituents of air. Let us try to summarize this lesson. In this lesson, we have defined what air is. We have also established the composition of air and establishing them using their percentages. And we have also considered reason why air is a mixture. We've explained it. I gave 3 examples to buttress that, and I also established how can we separate air into its constituents, the method that we can deploy. And we talked about fractional distillation, and we said there is a two-step process. The first step is the liquefaction of air, and then the second step is the separation using fractional distillation, and this capitalizes on their different boiling points. We also touched on the factors affecting air composition in this lesson, and there are 2 major factors, and these are temperature and then altitude. Okay, so we have established these, and then we have been able to do that. Okay. We have also looked at the uses of air components. We just talked about it. We looked at different air components and their various uses. Okay, so if you have any question on this lesson, please do well to put them in the comment section. I will pick them up and supply answers to the best of my ability. And I believe you'll be able to understand the concept better if after my explanation, if you have any questions or after my reaction or response to your questions. Okay. I will evaluate my lesson now, or this lesson that we just had. But before I go into the evaluation, I want to give you an opportunity to ask your own questions too. So if you have questions based on this lesson, you have a question, yeah, there's a gray area, you don't really understand what I've explained. So please go to the comment section, put your questions there, and then I will do justice to them. So let's evaluate this lesson using the following questions now. The gas commonly used in welding and metal fabrication is, if you know the answer, please put them in the comment section. Okay. The main reason nitrogen is used in food packaging is, look at the options: to enhance flavor, to make the food heavier, to create an unreactive environment or atmosphere, to increase oxygen content. If you know the answer, please put them in the comment section. Now, helium is preferred over hydrogen in balloons because it is, I touched on this, I talked about this earlier. So please, if you know the answer, if you've not forgotten it, please put them in the comment section and then I'll respond accordingly. Okay. So the ability of air to support life is mainly due to the presence of which of these gases? So put your answer in the comment section. Now, which of the following is not a noble gas present in air? Please also put them in the comment section, the answer, and then I will respond to them accordingly. The main reason nitrogen is used in food packaging, why is that? Please put your question in the comment section, and then I will react to them. I want to thank you for listening and for watching the video today. And I hope that you've learned something. So you've learned something. So please, the recording will still continue. I'll still keep on pushing different videos on the chemistry jam syllabus. So please don't forget to join in the next time as I will drop the next video on another topic entirely. Thank you for joining this lesson. I'll see you in the next class. Take care.